Hello everyone, hope you all are doing good. This is Sadman Al Fayyaz. I am extremely grateful to our professor for giving me the opportunity to present my project topic entitled Load Analysis of an Off-Grid Hybrid Power System using Microhydro and Diesel Power Technology in the remote areas of Bangladesh. In the next slide, I will be telling about the outlines. In this slide, I have arranged the project outline in several sections and I will be brushing through these sections. The introductory part will give the basic overview of hybrid power system and micro hydropower. The objective section describes the main purpose of this project. Then comes the potential micro hydropower site in Bangladesh where this preferred project can be implemented in possible ways. Then the hybrid power system setup description with some analysis for the turbine placement at optimum position through CFD simulation. Finally comes the outcome of this project where the load analysis of the system has been discussed along with the cost analysis as well. And then comes the conclusion part. So before going through this project, it is necessary to know about the hybrid power system. Basically, hybrid power system is such a technology that generates electricity from two or more sources, where the sources can be renewable or non-renewable. The main advantage of this power system is it can generate power from either one of the sources if the other source somehow fails to deliver power. Microhydropower, on the other hand, is the power scheme which delivers power from the water source. The term micro has been named as up to 100 kilowatt of power can be obtained from this. Micro hydropower technology is currently one of the most well-liked technologies as it has got some advantages like low installation, operation and maintenance cost, green energy generation, and most importantly, it has got the renewable source. As this proposed project has been conducted on the basis of the current situation in Bangladesh, there are some purposes behind this project. Firstly, the selection of suitable site where this preferred power system can be implemented. The power outcome from this system that will be helpful for the people living in the remote areas of Bangladesh, and the positive impact due to setting up this hybrid technology if possible. There are a lot of remote areas in Bangladesh where hydro sources are available. For this project, an ideal waterfall in Bangladesh has been selected, which is located in the Bandarban district that lies in the southern part of the country. The hydro source is basically a waterfall called Shoila Prabhat waterfall, which has the potential to deliver up to 10 kilowatt of power. It has the water flow rate of 100 liter per second with the head availability of 6 meter. In this slide, the overall design setup has been discussed here, where the micro hydropower unit has been designed by the help of a CAD software called SolidWorks. This micro hydropower technology is basically a gravitational water vortex power plant, which is an ultra-low head power generating micro hydropower technology. As from figure 2, it is seen that there is an intake channel which will be connected to the waterfall from where the flow of the water will come through. The turbine chamber where the water flow will create a swirling phenomenon called the vorticity, and there will be a turbine installed within the turbine chamber to extract the power. After generating the vortex, the water will flow out from the outlet orifice and again merge with the waterfall. In this project, the hybrid power system has been developed from two different sources, which are the micro hydro power source that has already been explained, and the next one is the non-renewable power source, which will be provided by a diesel generator. The main purpose of keeping the diesel generator as the alternate source of power generation is because it can provide the power in the critical situation and does not need to depend on the availability of the source. Figure 3 describes about the overall setup of the power system where the two energy sources are connected with the AC bus bar. There is a converter for the storage connected with the DC bus bar that will store the excess electricity as well. The overall setup has been simulated through the Homer Pro, which is basically a specialized microgrid electrical power system software, and the outcomes has been discussed later on this presentation. For verifying the optimum position for the vortex turbine installation, an investigation has been carried out by the help of ANSYS flow and CFD simulation by giving necessary boundary conditions. Figure 4 shows the velocity streamlines of the vortex formation within the microhydropower system, and Figure 5 shows the velocity contours of the vortex formation. In the post-processing section, it has been observed that the maximum obtainable velocity of water is achievable at the 28% of height from the bottom of the turbine chamber, which is suitable enough to give sufficient amount of torque to the vortex turbine. Therefore, this will help the turbine to harness the maximum possible power from the vorticity, and for this reason, the turbine can be installed at this preferred position for maximum power extraction. Now comes the most important section. As given in Figure 6, the daily load profile of Bandarbahn district has been shown, which is around 3 kW. After conducting the simulation of the hybrid power system by the help of Homer Pro software, two feasible load profiles were obtained. One is the electricity generation through diesel generator that has been shown in Figure 7, and the other is the generation of electricity from hybrid power system that has been depicted in Figure 8. From the Figure 7 and 8, it has been clearly observed that the annual electricity generated through the hybrid power system brings out the most efficient result than the single power source, where the microhydropower unit delivers the maximum amount of load than the diesel generator. Both of the sources from hybrid power system gives satisfactory outcomes, which is sufficient enough to provide electricity to the people living within a small residential area of at least 50 houses. In terms of feasibility, the hybrid power system has got some good results. The outcome shows that the break-even point of the lowest cost system, which is the hybrid power system, is at around 7 years with an internal rate of return, that is the IRR, of 14%, and the return rate on investment, that is the ROI, of 10%, which is comparatively a good output in terms of project lifetime as shown in Figure 9. Also in this figure, the cost summary has been depicted where the NPC and LCOE cost of the hybrid power system is lower than the base case, which is the single power generating source from diesel generator. Though the initial capital cost of the hybrid power system is pretty high, but the operation and maintenance costs are reasonably lower than the base case. Now comes the conclusion part. After going through investigation, some certain core factors has been observed which supports the implementation of this hybrid power system in the preferred area of Bangladesh. Establishing this project will provide electricity to the people living in this remote area. Renewable source has been utilized properly. The overall system is pretty much cost effective. This technology will help us to reduce the environmental pollution, and finally, it will bring a positive impact in terms of the country's economy as well. This proposed project can be a fruitful option for Bangladesh as the majority of the power plants there are fueled through non-renewable sources. And lastly, these are the references which are used to complete this project and to cover my presentation topic as well. And this brings us to the end of the presentation. I am extremely grateful to our professor once again for the opportunity to present my topic, and I'm thankful to the audiences for being with me throughout the presentation. Thank you all once again for your precious time.